Everybody.
Hey, Brian.
Hey, I'm actually traveling today, so I'm not going to be able to share my screen or anything. Um, there's a couple of topics I think we can discuss about. David had some questions, but I'll wait to see if he comes on. David, um, not David Kruckmeyer.
Yeah.
Um, Jeff, you had a new C2C spec. Um, I had just taken a look at that. I don't think I only added one silly comment or something like that. Um, David Kruckmeyer's comments are always much more insightful than mine could ever be. Um, I guess one thing I'd like to bring up on that is um, David made a comment about the credits and stuff like that. And
Yeah.
there are multiple ways of doing credits. You talked about revising the ways of doing credits and stuff. I think there's a couple of things in there that were potential variations in how people use the variant, a couple of different options. Now to think about it, I don't know if you call those out in like like I think one of the things that makes a lot of the other variants easy to use is that we give the variant a very specific name and say these are all the options under that name. I don't know if that's really possible with C2C because of the way the variables work, but if you think that there's ways of easily doing those buckets, then I think that makes it's potentially a way to drive people towards a finite set of implementations. Um,
Yeah.
Especially on like the crediting, where you have all those possible options of doing crediting and stuff like that, and you won't necessarily interoperate with people that don't do the crediting the same way. I'd also say like on those kinds of things, because the way that we talk about the credits is they're used like when C2C talks about their credits, they're using them in a kind of a unified controller mm, with UCIe, right? Because there's no other credits there on the UCIe side, whereas the TLL has its own credits. And we are, I think in your document, you're kind of mixing the stacks. Like you're assuming it's all like one long FIFO or it's one controller or you have a unified back pressure where you can treat it like one FIFO. Um, I think some statements on that would be good as well. And maybe again, those fall into the buckets that I'm thinking that we're talking about here, like, if you use credits this way, it's assuming this kind of technical implementation with the way you're doing the the way you're counting credits and the way you're doing the FIFO, right? And so it's very clear how those are being counted on both sides. You get what I'm saying?
Yeah, I guess just some comments about C2C. I think it's heavily tied to the knock implementation potentially.
Hmm.
Because they have these what is it? Resource planes, right? That are associated with the request channel. So it essentially breaks up a request channel into 8 separate, or can be a shared. Actually, it's 9, right? Because there's a shared and then 8 unique identified credits. So, and I think this has to do with like back pressure or non-blocking behavior and everything in a knock implementation. Just in general, though, I mean, the C2C is much more complicated in how it handles all the crediting. So, I pulled together some thoughts on TLL 2.0, features and stuff to consider. And I think my conclusion, looking at all the crediting across the board is if we can just bring all the inputs to the variant or profile level, and then, you have some specific logic that figures out based on different inputs, how to credit each one of the TLP streams and passes it back down. And that way the complexity is kind of moved away from the critical TLL controller, if that makes sense.
Oh,
And
sorry, I was talking on mute. So
okay.
yeah, I think you have two. There's two high level decisions you have to make. Number one, are TLR credits the same thing as C2C credits, right? Because one's actually doing, end to end, virtual FIFO in your fabric, and one is doing, basically the FIFO just in the TLO controller, right? And again, depending on what bus architecture you have and how tied the controllers are together, you can treat them as one thing or you can treat them as separate things.
Hmm.
And so, and then on top of that, you have various buckets that you can use for returning the two different types of credits that you have, right? And
Yeah.
you can and again, whether they're all adding to one number or whether they're adding to two separate numbers that you have to track is the question.
Yeah.
Um, and I think that's fine if that final answer is in the profile. It always should be in the profile anyway. I think for your spec, I think the only thing I would say that would be nice to add is to make those things extremely explicit in terms of like what options a person has to do in the profile.
Mm.
And so, or the problems they have to solve in the profile when they're using this variant. Because I think for the other buses,
Yeah.
it's really just you pick a name and and then because there's no other crediting or anything like that, there's not a lot of other things to solve, right? but with with a lot of our, with like the sideband and stuff like that,
Hmm.
we try and call out, hey, these are the implementation dependent things that you have to be very explicit about. These are the IDs, things like that, right? But nobody
Hmm.
misses something when we're talking about interoperability. I think it's just kind of the same thing with yours. It's fine, you have the options. I think we just need to, you know, for lack of a better term, Chinese menu it, A, B, C.
Yeah.
Like, if you get a little from column, and if the profile says a little from column A, a little from column B, that's fine. And they can go off on the weeds in terms of the complexity of their implementation, but just simplifying it down in terms of a specification is would be my feedback on that.
Yeah. And I think where I complicated things a little bit was trying to mix the TLL crediting with the C2C crediting. Because otherwise,
Yeah, yeah.
yeah,
Well,
right?
well, that's fine. Like I said, there is a theoretical implementation of this, like where they are just one number, right, at the end of the day, and you
Yeah.
can use the mechanisms. Mm. So having that capability is not a bad thing. I think, just calling out,
Yeah.
that these can be interpreted multiple ways.
Yeah.
And that question has to be answered if a profile uses this variant.
Hmm. Yeah. Okay. And then did you look at the CHI variant?
No, I haven't. I
Okay.
haven't. Sorry. I've been so like
I,
people just keep starting projects all around me.
um, yeah, that's the one I'm kind of more interested in going over because that's more of a straightforward, how do I take the previous CHI variants, like our V1 profile, which specifies variants as well, and I look at C2C, how do I mix all that together and come out with a CHI variant that has multiple configurations or yeah, variant configurations like you had in the AXI.
Yeah. Yeah, I looked at your stuff before. I just haven't looked at the updates. Again,
Yeah.
what you had before all makes sense. And I'm not super familiar with the changes that they've made in the updated Chai or whatever the current, not Chai,
G.
whatever Chai G or whatever the current one is.
GG.
Yeah. Um, so yeah, no, yeah, I need to brush up on the changes in that spec too to understand probably what how some of these things. But
Yeah.
and yours and Ventana's and David's decisions in the past have been on point for most of that stuff. I
Mhm.
think the only arguments we ever had on that stuff was specifically on disaggregating some of the more disaggregating some of the more complicated features that we were trying to also add to it. But again, I don't. Like I said, I'll try and take a look at next week.
Yeah, that's fine.
Um,
Okay.
um, okay, yeah. So and Jeff, you're all set for everything you need for Global Summit, right? Um, I think I'm still in the process of doing. I had to. My guys review the slides, my slides too, and so I think the only thing I'm doing to mine. I sent you my deck, and Helia, you mentioned another background slide as well. So I think I'm going to add just a little bit to mine before I submit. I'm having a little bit of problem even submitting it, so I might hopefully a new can help me with that because the other people that are asked with that responsibility for helping people just don't seem to respond to emails. Um, Actually, quick question for you, Jeff. Are you submitting your slides through the portal thing, the FNIB based
Yeah.
login?
Yep.
Yeah, that's totally broken for me. So I don't know what to anyway.
Okay.
Don't need to talk about technical problems here, I guess. Um let's see, what was the other thing? Oh yeah, yeah, David, Woody Fat, another thing that he was not on. So we can probably talk about that real briefly.
Okay.
Um, he sent me an email asking about me and Helia about asking about um, different slice configurations. So, and looking back at our transactions back, I don't think we support more than 4 slices right now. Mm. If you haven't seen anything from your side that's supporting more than 4 slices, right?
No.
Yeah, because he was talking about doing like 384 or 512 bit interfaces and stuff like that. And I'm like, I don't think we, I don't think we have anything. I think you'd need a new fragment size for that as well, right? Which changes some of the granular ordering and everything. Mm. I don't know. I need to think about
Yeah.
that some more. He had a lot of bow spec questions too. So,
Yeah, I
oh,
mean,
actually,
we're right now on UCIe, so we're just constrained by the UCIe spec, whatever it is, and that's 4 modules.
yeah, it's a little easier from
Yeah.
that side.
Yeah. And I don't know how this would complicate it. I'd have to go look at it as well. I kind of ignore that aspect, those aspects right now.
The physical side. Yeah, everything's easier when you don't care about the physical side.
Well, I just assume like all the physical mapping to the phi, that's all pretty straightforward and we got a good handle on it. But now that you're saying, oh, we may want to go to a different width, then yeah, it may change everything. I don't know.
Yeah,
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 I just have not put any attention into it, so that's why.
yeah. I think that's it from my side. Does anybody else have anything that they want to bring up?
Yeah, I mean, I'd like to present the proposals for TLL 2.0. I think
Okay,
in the last call that would be something we might want to talk about this week.
sure.
And I put thoughts together and we can go over them.
Go ahead. Yeah.
Can everybody see that okay? I know you can't, Brian, but
No, well, I'm on my phone, but I can see it
okay,
fine.
you can see it. All
Yep,
right,
you
so
can see
I
it.
tried, yes, you can see it?
Yes.
Okay, perfect. Okay, so as I've been going through all these mappings, it's generated a lot of ideas on things to consider. Um, some of these, I think, I think there's good reasons maybe to move, and then some of them are just more questions. So I wanted to kind of solicit input from the group. So the first thing is, the TLP type, we have that being 6 bits. C2C has it 4 bits, and actually we can minimize it. It gives us more, transactional bandwidth. And so I'd like to see if we can get down to 4-bit encodings. And the way I think we can do that is we assign the values at boot time. Um, in which case, then you're limited, instead of it being like a static list of streams, it's just a list of streams that are active on a link at a given point in time. So,
So do
that's,
you?
go ahead.
So okay, if you have 4 bits, that means there's 16 possible streams,
Yep.
and the streams are static to the link, or are they done, or can you like reassign like mid link? Could you overload a single stream with multiple virtual streams?
Yeah, I think you can. I think what you're saying is, for example, if you're in IO Hub, you probably have to support a lot of different streams.
Hmm.
You kind of select out of that static list, what's going to be active when you attach a spoke chiplet to it. But a spoke
Okay.
chiplet probably has, the minimized list, right? I'm assuming, but maybe it could be, selected from the static list on the spoke side as well.
Okay.
Um,
Yeah, that's fine. I think I just want to clarify what you're saying when you were talking about them established at boot time. Like what exactly is configurable here? And then so I think with the current types, right? I think it's very much kind of tied to to profiles, right? The profile bits, like what all those IDs are and how they do it. Are you talking about changing how those are assigned to, or it really just kind of same thing as we're currently today, just reducing the number of possible strings?
Now, so the TLP header, was thinking about the aux bits and all that reserved, and I don't think it makes sense to reserve all that bandwidth up front for each TLP. So I'm kind of in favor of just having a 4-bit, TLP type, and then 6-bit ECC, which you need for the TLP header, and then just have the rest be payload, 22 bits of payload. And when I look at that 22 bits versus 14 bits, occasionally I'll pick up a granule, I'll have one less granule in a particular configuration. So it just gives you more flexibility in how you pack the data, and you can always use that payload for anything you want in terms of, aux signaling. And part of that is,
Well, sort of. Like I think the problem is when we say payload, right? We're talking about a a transaction level. We're talking about like basically a protocol. But the way the spec is written right now, you have basically a protocol packet, right? Which is just the payload, right? And
Mhm.
then that maps directly into that payload slot on the TLP, right?
Yeah.
And so if you want more like virtual channels or whatever there, right, it has to be handled at the protocol level the way we're kind of dealing with it now, right? There's not another logic layer there to disambiguate that. So that's kind of what the why some of that I guess is in the TLP, because that's basically powering that mux between those two things. So you can turn those, so you can easily go ahead and break that into a channel. So if you put more into the
Yeah.
protocol packet, then it becomes more complicated from an implementation side where you have to have another FIFO or whatever it is that's breaking that out to another set of wires and yada yada yada. So I think there is still value in having a larger TLP size, potential TLP header size, or just larger number of bits in the TLP header in some implementations. I think I'm fine making those more flexible. And I think I'm fine also having a flavor that is a smaller header size. Like you said, maybe this is a boot time decision or a implementation level decision, like we give a big header and a small header, and you pick, right? Um, yeah,
Yeah.
I don't have any problem with that. I'm a little wary of completely taking away that flexibility though.
Hmm.
Does that make sense?
Um, Maybe, but so an example is like on C2C, the message formats have essentially virtual channels, right? I mean, they have a,
Yeah, well, that's kind of a weird use case. I mean, that's a corner case compared to our other other buses, since that is a pre-encapsulation of a bus before getting to our encapsulation of the bus, right? So they already have that layer of the stack already implemented, and there's another controller there already by default, right? I think like when you're looking at say AXI or whatever, you're not expecting another controller. You're expecting like this to drive a bus, right? On the other side, there's probably a staging FIFO there, in order to break that up. But you're driving almost transactional wires there coming right out of the TLL controller, right? Where you won't be with Chi C to C, you're going directly into a Chi C to C controller, or it's part of the same logic. So it's a little bit different, right? But
I don't,
I don't disagree that, adding some flexibility in the TLP header is, that sounds fine.
well, I guess what I would say is just, could we start out with a general payload and then if we need to at some point, I guess you could have a configuration where those higher order bits become something. But it seems like if we're going to reserve that bandwidth, we should have a good purpose for it, right? That applies to all potential TLP streams. Otherwise, we're just throwing away bandwidth.
Like I said, I agree that, some use cases like that it makes sense to have those bits back. I guess where I'm trying to say is the reason that those were allocated before was so the implementation would look a specific way. And if you
Mhm.
move, if you take those bits out, it potentially doesn't.
Yeah.
So, you're making more assumptions about the implementation. Um, so,
Mm.
okay, yeah.
Yeah, I mean,
So
what they're
I
used
think,
for now most of the time is crediting, right? And so I was looking to go define the credit format to just deal with credits in general. And then you have to ask yourself the question, what do you use that aux field for? Right. And I looked at trade-offs between if you're always communicating credits on the TLPs versus if it's a specific TLP credit that you send, occasionally. And I think it's probably better to have the CRD credit only, that TLP, that specific TLP type to communicate the credit data rather than communicating it in the TLP header.
yeah.
Over.
Well, I mean, I don't disagree.
Yeah.
It's kind of an implementation dependent thing, right? Like if you have deep FIFOs, then there's absolutely no problem just doing credit packets, right? Because you're able to pass way more credits at a given time. You can wait until it hits the watermark, pass all the
Yeah.
credits
Good
over.
point.
You're all good. So like
Yep.
if you have a deep FIFO, there's no problem doing that. But if you have a really shallow FIFO,
Yeah.
and if you're trying to get like an absolute minimum implementation, and
Yeah.
if your traffic is symmetric anyway all the time, then having in the aux field is easier, right? You're okay sacrificing a little bandwidth in order to save area. And so,
Yeah.
again, having flexibility to do it both ways, I think is still a win. Um, I am okay if we make the aux field optional,
Yeah.
if that's where you're trying to drive. But I have concerns getting rid of it before we have um, market feedback, if that makes sense. Right?
Yeah.
Because we're
No, I get
all
your point. Yeah, I get your point. I think that was, in my mind, that's the biggest trade-off, right? Is how long can you sustain TLPs coming in before you have to credit them back, right? And it's the buffer.
right.
Yeah.
Absolutely.
Yeah. Okay. Um, but then, when I was looking at the crediting format we have today, it's pretty inefficient, right? Because you're crediting a single, let's call it credit field,
Uh-huh.
per TLP call. And so here what I'm suggesting is we turn that into 7 3-bit fields. And then we have a bank select, which gives us a total of 14 credit fields that we can communicate with each call of CRD. And then, yeah. So,
Yeah, okay. Okay. I'd have to think about that.
yeah, it
Not
gets
sure what the trade-off is.
it just makes when you're using the CRD TLP, it just makes it more efficient in terms of passing credit.
Okay.
You're doing multiple at a time. The wired, I haven't thought of any changes here. The only thing I'm concerned with is maybe 1,000 wires might be a bit much in terms of how you're muxing all that. But yeah, so that was my only question there is, does it make sense to, have to limit fewer than 1K wires. Um, and then the messaging type, it's here
Well,
what I'm
so I got a quick question for you here.
okay.
Like, what do you think people are doing with wires most of the time? Because there's like, I think the only use cases I've really seen are um, the coherency requests and potentially power requests, and potentially people want if they want to get lazy and they do interrupts, right? Can you
Yeah,
think of anything else people are doing with virtual wires?
not off the top of my head, no.
Okay,
So
but
yeah, 1,000 wires seems like a lot, right?
yeah, it's a lot, and they're still all relatively from the point of a view of a bus transaction, low latency, right? Not low latency. I'm sorry, high latency. They're high latency tolerant. Like even power requests or thermal requests, right? We're talking about um, microseconds. He's got plenty of time to respond to these things, so
hmm
it's not that big of a deal. I guess interrupts would be the biggest probably low latency thing.
hmm
And if people really want low latency, they can make them MSIs. So, okay. Yeah. So I just want to make sure there's not a use case that we're, missing in the market to improve virtual wires if we're changing them.
No, and I've been thinking about it more kind of in a general sense, like if you have multiple wires, there could be interdependencies between them. Um, or you may want to deal with them more in a time critical fashion, or prioritize them to where here are critical signals and non-critical signals. There's some of those thoughts rattling around in my head, which you kind of see in the VWX, comments, the interdependency there, the timing, or do you want to specify certain timing, like when the message gets over the other side, do you want to delay when those signals get transitioned or they get transitioned right away? Um, Stuff like that.
Mhm.
So I've just kind of left that as, hey, that's something we probably need to investigate more. So,
Okay.
okay. I'm proposing to remove the idle TLP. I think it just fills the LLP granules, and I think if you know the payload size for the previous TLP, you know when that ends, on which granule that ends, and you know the start of the next one on the TLP start bit. So I'm not sure what you're getting by communicating the idle TLP. So I'm
Ask David. I never understood
yeah.
that either, honestly.
Okay.
There is a requirement to count clocks, as we talked about before, right? In order to know what the framing is. But
Mhm.
like whether it's zeros or not, I'm not sure why it matters. So
Okay.
I think you should probably ask Dave Breckmeyer because there may be something we're missing there. And again, maybe that's just the idle TLP is kind of just a way to make people save power.
Y-
So
y- Yeah, I don't know. I've asked him and I haven't got a response on it yet, so I'll ask him further. I thought maybe somebody on this call might know, oh, wait a minute, you can't do that because of this reason. And that would be great if I have that
right.
info.
Well, again, I think it's just a logical construct to make it clear that you have to count the clocks.
Okay. Okay. Let's see what else. Messages. David had indicated that that was really about just writing a register that's under software control. But I'm thinking it might be interesting to link those into FIFOs or have some kind of crediting on that, so that you don't overrun a FIFO or a register or whatever, you have on the other side of that. And I'm thinking, like a 64-bit interface on the TLL controller, but we can only transmit 16 bits, and so you have 2 bits for like a word select to steer that data. And then you have, extra bits there where you can steer it to different destinations or, different FIFOs. But
I'm not sure. I'm not sure I'm following you here. Sorry. Can you? Sorry. Which credits are we talking about again?
oh, this is the message TLP. So
Oh,
it's
okay. All right.
16-bit data. You can steer that to a 64-bit word or whatever with 2 bits. You can steer each one of the 16 bits to there. And then you have 4 bits left over where you can send it to different destinations.
And so what are we using this for?
I don't know. I'm thinking in the systems group, we're talking about configuration or like a messaging protocol that's in UCIe and how we transmit that. So would we use, a message for that? David seems to think about this as more of a software mechanism,
Yeah.
visible to software, right?
I mean,
So
like, I guess the question is what's the benefit of that versus just having another,
yeah,
low width variant that, people can include for doing, systems management traffic.
yeah,
I mean, the only advantage with having another, mm, another packet type would be, if it has a different kind of priority and the way we things, right? Mm. Because you could potentially, again, well, this is another question I guess I wanted to, bring up would be, one of our big limitations of the current spec is you can only have one TLP header per LLP of the same type, right? And
yeah.
so the question would be whether we want to keep that constraint. And if we do, then you could potentially, if we keep that constraint, then this has the added values. You could always include one of these if you want to have like you want to guarantee a certain amount of bandwidth for these high priority messages, right, that are being managed by a system controller or something like that. So I guess that would be the
Yeah.
benefit if you want to,
Yeah.
if we keep that constraint. But if we remove that constraint, then like I guess David Prittmeyer said, then it becomes a software issue, right? Then you just have to deal with um, that channel being dealt with as part of the profile.
Yeah, I think these special TLPs that are kind of defined in the TLL, in my mind, they kind of have a different output source than the general TLP. The general TLP is just some signal payload that's going to drive some wires in the design. Credit is special because it's, crediting that whole mechanism of communication. Virtual wires is just controlling some specific wires on the interface, and the message seems to be something that's visible to software layer, right? Granted, you can
Um,
go do you can do a TLP transaction to write some data and pick it up in the software realm somewhere, right?
right. Yeah.
This message is, software visible on the link, right?
Software visible on the link. I mean, like,
Well, it's
yeah,
just exposed as part of the link controller.
yeah, but I mean, that's semantics, right?
Yeah, maybe.
I mean, this just gets dumped into a place in memory and an interrupt gets fired when the message is full, right?
Yeah,
Um, Again, UCIe uses a system management DMTF
yeah,
messaging stack, right? And really, so it's just a way of um, of packing commands into packets, right? And then they have a sideband and a main band
mhm,
mapping of that same stack, right? And
mhm,
DMTF has like all of the there's like three other layer names there, but they have ways of distributing this among multiple potential targets and passing them along and stuff. So there's these little higher level microcontroller software implications of all this stuff.
yeah,
But um, I don't know. Again, that's just another way of of all saying the same thing, whether it's whether it's a explicit register write or whether it's this message thing, it goes to a fixed register, right?
Mhm.
One's slightly more efficient. Again, I don't. I think for the volume of traffic that are on these things, it's all in the weeds. So I think the question here is whether we think that there is a system level requirement for something that's higher priority or
Mm.
a guaranteed level of bandwidth or something like that for this traffic that would require this type of thing. I don't have any problem doing this, to be clear, right? I'm just saying I don't know whether it would actually get used outside of. I'm not sure whether. I guess the question is whether the question is whether it would actually get used in implementations, I guess, and
Yeah.
what values it brings.
Yeah, and I'm not entirely sure. I know it got
Mhm.
defined in the original TLL, so I was just trying to look at how to make it maybe a bit more useful. Um, but I'm not convinced on the need for it.
Yeah, yeah. I mean, because we don't use it in any of the profiles right now.
Yep.
There's a whole lot of them.
Yeah.
I don't know, but I guess to your point though, I think it would be good if we can figure out a way to use them and then give it some more flexibility.
Hmm.
Yeah.
Okay. Um, so I'm gonna drop down to kind of the LLP stuff because I think that's quite interesting. Um, but the film is limited to one. So, there's limitations in terms of what you can transmit within an LLP packet.
Mhm.
I don't think it makes any sense to limit the number of virtual wire TLPs that happen. It's just and I guess it could be to the same wire as well, right? And it just takes the latest
Well,
state.
the reason that we have that limit is the way that we do the encoding in our first header of the LLP, right? So you have the first LLP header, right? And it tells you where the headers are for the other ones, right? And so if we change how many virtual wire packets or how many packets in general that is, then we have to change that how that encoding works, right?
I don't think so, because it's just a bit vector that says where a TLP header exists.
We don't have a type in there too.
No, no, it's just as far as I know, it's a bit field.
Okay. So I guess the reason it's limited is to make the controller mux, make the mux afterwards deterministic, right? Because I guess if you had multiple of the other types, then
No,
you have to have that many entries. You have to be able to absorb that many entries. So I guess, yeah, okay. Okay, that makes more sense.
I think the reason why David did this is he wanted to limit the bandwidth of virtual wires versus the other TLPs. So if we relax this restriction,
But
then I think we
but
have to look at prioritization
but
of the.
that's a requirement for all of the all the TLPs. You can only have one type of TLP or one of each type of TLP in an LLP, right? Like you
Mm.
can't have two messages. You can't have two virtual wires, etc. Right? It's not just virtual wires, right?
It's not just virtual wires, but virtual wires seems like one that you would want to relax this on,
Okay.
right? And there could be others as well, right? I think the regular TLPs, they tend to have a larger payload, so it's not so big of a concern, right? Because you're already taking out multiple granules for them. And when you do like, well, I don't know about AXI, but for like CHI, you're having to do a bunch of requests and DATs and snoops. So it's not really a major limitation, I think. And I guess if you had kind of a shadow storage for your protocol. So in other words, you're working on the interface as you're receiving data, and then at some point you're going to update your interface. And I think that might get you out of the limitation of not being able to do multiple streams, right?
Yeah. Yeah.
Yeah,
I mean, yeah, you're gonna
I
have
think
a
that's what you're talking about.
Yeah, absolutely. I mean, that's the requirement. That's the issue here. If you have a single FIFO for the virtual wire, so to say, right, that when they're getting processed and loaded into registry,
Mhm.
right? This means that if you allow two virtual wires in the same LP, that FIFO has to be 2 deep, right? Well, right now it's 1 deep. And I don't, that's fine. I mean, we should probably look at all the different types and all the different use cases here and make sure that that's not the only use case we want to relax that on. Which is kind of what I was going back to earlier as well, too. I think, um, there's, especially with narrow variants, right?
Mhm.
It might make sense to make this more flexible on those too. If but I don't know. I now that we're doing this, I have to think about it a little bit more about what areas that might work in.
Yeah, and part of this too is the nature of wires, right? As long as you're processing them in order, if they even went to the same virtual wire, it just means you just updated it and you missed the previous one, right? Potentially, or it gets updated pretty close to one another. Maybe it's a behavior you want, but that index really
Well,
sets
yeah,
the
a lot
different.
of times you just want to toggle it, but I think you have to have. Oh, that does bring up a good point though, because I mean, like right now, you're limited by how often that can happen. But
Yeah.
now, like you said, they are potentially back to back, so you might have a minimum amount of timing that you have to specify on that link.
Mhm.
Or in our specification, we just say that minimum timing has to be specified in the profile.
Yeah.
Okay.
Okay. And then the big one I started thinking about today, and I don't know if it's possible, but if you look at the LLP header, we only have like a 15-bit vector because there's 15 slots. There you have the LLP header in one granule slot, and then you have 15 where you can put TLPs in. Well, I'm just wondering, could we just extend that all the way out to fill out that LLP header? So essentially, we'd have the LLP header plus 26 granules. And so you could reduce the overhead of the LLP. It's just, I don't know if there's what the reason was that the LLP size was limited to, I think, a power of 2, right? 512 bits. Does that make sense?
No, so you're saying change the overall LLP size?
Yeah. Because right now, if you look at the LLP header, the TLP start is limited to 15 bits, that bit vector.
Mm-hmm.
There's 15 slots there. So
Yeah.
you're essentially wasting that LLP header part of it, right? And I'm just wondering, can we extend that bit vector to be 26 bits and then have 26 granules in an LLP? And I don't know if there's a reason why we have granule 0 in the position it is, and it always has to be there.
Um, I assume it's to simplify the hardware so it knows where to decode the header.
Yeah.
Um, but yeah, I don't know what the implications of this are. Again, that's probably another question to David.
Yeah. Okay. I'll ask him. But I thought maybe others on the call might, be familiar with these kind of implementations and, you know, could also provide input. So I put it on here. And then the rest of this is really kind of how I'm thinking about layering the different elements in this whole transport layer. So you have the PHY. Here I'm suggesting, should we have the adapter and sideband actually in the PHY specification like it is in UCIe, or if it stays in the TLL specification. Um, the TLL specification, I'm trying to define that as something that could be a latency critical fixed design. So it's more generic in nature. And then in the variants and profiles tends to be more, I call it auto-generated logic, right? it's less time critical and everything, and it provides more flexibility. And we could have some like CDX tools or something that would generate this kind of logic. And then I'm kind of talking about where things are defined in the variants and profiles and where they're actually getting assigned values and things. I don't know if there's enough time to go through all that, but that's kind of how I was trying to partition this all the way out to the SoC interfaces where you're connecting that protocol interface and the wired interface. And here, I mean, this is general.
Yeah, we've kind of intentionally not done that. But okay, yeah, we can. I think I think it's probably good to define how that gets defined, whether we do it explicitly ourselves or not.
Yeah, I mean, when I was working through the variants, it was like, for example, there's the wire, right? The coherency, joining the coherency domain
Yep.
wire. And when I looked at how it was defined, we defined like 32 virtual wires and we're only using one of them. So it like tells me, oh, wait a minute, the variant just wants to specify which wires you need. And hey, I need a virtual wire for this. But
Yep.
when you boil that up to the profile, then that profile is going to define the number of virtual wires, and I just assign that particular one in the variant to one of the virtual wires.
Right.
So I try to methodically think through that and say, how would you go? Where would you put this in the different buckets?
Right. Well, it's the same goes for the IDs as well, right? Since you're going to be mixing potentially multiple variants together, you have to be able to put those IDs in the right buckets so they don't collide.
Yeah, and in particular that one, if we have some kind of configuration, like discovery configuration, firmware, then maybe we have, a group of static IDs that are wider and we can define them as, in a database. And then they actually get assigned to some 4-bit dynamic type, at boot time. It's either that or the firmware just knows, oh, I have this type of stream, stream A on one side of the link, F
Yeah.
on the other, and
Yeah.
yeah.
I imagine the initial implementation was envisioned more as if those wires were directly driving a mux. But, yeah, that could be, well, given the high speed nature of this stuff, I would be a little wary of this being software routable. But it's something we can talk about more, then definitely some implementations might benefit from that. But well,
Mhm.
definitely from a discoverability point of view, just find out like what the options are available to make sure they can fit with the mux and stuff you have on your side either way.
Mhm.
I don't, we've talked about that before. We've explicitly said we didn't want to deal with discovery on the first one, but
Yeah.
we can definitely talk through like what that would look like going forward if we add that.
Yeah, and if it's really critical stuff, it belongs like in the TLL. I'm calling it like the TLL controller.
Yeah.
You could have like a mux tree, right? So the first number of indices or whatever are critical ones that you expect to, you want to have very good optimized latency for. And then other ones could mux them later in the tree.
Yeah.
Yeah.
Sure.
So,
Yeah, I mean that if especially if you have non-bus level traffic, that makes sense too.
mhm.
Okay.
Okay.
Yeah. Is this in the doc that you had sent me before?
Yeah,
Or
it's
is
in
this a
my
new doc?
private area, so I'm probably at the point where I can push it to the work in process drive if you
Yeah,
want to put it
I think
there.
this would be good, and maybe we can talk offline about what a next topic would be, in terms of like what we want. This is a good. These are all very good. I think I had one or two things I'd been thinking of too. We can add, and then we can use these as topics for driving agendas and talking about this.
Yeah.
I'd also like to talk about eventually, like how how we want to talk about, backwards compatibility, whether we're even going to try or whether
Hmm.
we're, you know, once we've decided, what are some of the must-have features here, what do they preclude it going forward?
Yeah.
Yeah, it's probably better to talk about what we want first before we talk about whether we can accomplish that.
Yeah, agree. Um, yeah, I think the only thing that for me that is interesting to resolve sooner rather than later is the crediting scheme and these credit fields. Because I wanted to go ahead and move the CC more in the direction of, this kind of CRD TLP. So, and actually in the CHI variant, I put a note in there about defining TLPs like in the structure.
Right.
Yeah.
Um, yeah, I'll try. Like I said, I'll try and take a look at what you have here with regards to the 3-bit fields and stuff like that.
Yeah.
Yeah, I don't know. I have to think about that, I guess.
Yeah, sure. Okay.
We're almost out of time. Anything else, guys? Thanks, Jeff, for presenting that. That was
Yeah.
a really good, comprehensive list of things we can work on here.
A
Yeah.
quick one here, maybe related to what Jeff is also presenting. How can we share that this is, so we were very focused on sideband in TLL working group. Now we are kind of going back to the main band and bringing that conversation. Maybe it would worth announcing that in our OCE meeting on Friday. What do you think, guys? So that if people are not interested in sideband by now, but now they are interested in main band, can start joining.
Yeah, for
Yeah.
sure. And anything that drums up more participation.
Yeah, definitely. I will tell you, I've been attending the system meetings and they're starting to look at how to leverage these variants and profiles in what they're
Yeah.
doing.
Yeah, I think another thing would be good from the systems team is whether we're missing any variants. Like I've looked in the past at like tile link and all sorts of other kinds of buses, and we talked about what was it, die bus or something for a while too.
Yeah.
Anyway, there's a whole bunch that we can probably not spend too much effort on and create mappings for if people want to start looking at efficiencies and stuff. But there's just not really any directive to do that
Yeah.
other than EMBA. So if they have other ideas on things that need to be done there, then we can take those as agenda topics too.
Yeah, but I think making it visible at the at the project level, the OC project level would be helpful.
Yeah.
To get participation.
Okay, great.
And I think in both our talks at the OCP Global Summit, that'll be a big focus, right? Of trying to encourage people to come join calls and participate.
Yep.
Yeah.
Okay, thanks.
Yeah.
Well, I think that's it, guys. Thanks for joining. And let's see. The next one during Global Summit. Actually, no, it's the week after. Oh, no, wait. The summit is the 14th, 15th, 16th. Yeah, okay. So it's the week before. All right. So I guess I'll see you guys on the 9th, for our next meeting.
Okay.
And Jeff, we could talk offline and we can talk about a little bit about your more pressing concerns on C2C, and maybe we'll figure out what come to the table with pick one of these topics and both we come to the table with some ideas on that.
Yeah, I mean, just, since your time is limited, I would focus on the CHI variant
Okay.
I pulled together and just the crediting scheme that I'm proposing. I think
Okay,
those
we'll
are
do.
big topics that, would be good to get your feedback on.
Cool.
Okay.
All right, talk to you guys later.
Yep.
Bye-bye.
Bye.
Bye.